Alright. I think I'm live now. Can someone confirm if I'm live? Okay. Just let me know in the chat if I'm live or not. I don't have any chat as of now. Let me check. Okay, I think I'm live now. I just don't have anyone to tell me if I'm live or not. Let me just check from my phone. Yes, I am live. Cool. Let's wait for a minute or two for people to join. I don't have many people watching as of now. Good to see you, Sharon says. Yeah, good to see you too as well. Alright, so let me see how many questions were you able to solve today. We are going to be solving Codeforces around 847 Div-3, and there were 7 questions. I'll be solving the first 5 because even I could solve the first 5, and I think those are the 5 questions which most of you would want to know the answers for. So yeah, Shubham says 4, really nice. Fifth question is actually a tricky question. Even I actually just found out like okay, it's working like this, and then I realized like how the logic works. I was actually able to find the answer first because of I wrote some brute force, and through that I like saw that okay, it's a pattern, and then I thought about the logic like how this is working. So yeah, but yeah, first 4 really nice. Real night bot says start with the fifth one, bhaiya. I'm actually gonna go in order wise only. I'll start from the very first problem. But since all the first 5 problems are easy, I think I'll be able to complete all the 5 in like 30-35 minutes. Shubham also says, can you please explain question 5 first? Just wait for 20-25 minutes. I'm pretty sure I'll come to problem E in like 20 minutes. Alright, so real Nightbot says thumbs up. Okay. Bhanu says, भाई आपने Adobe क्यों छोड़ दी? Actually, like I actually found a really nice opportunity in Microsoft, and the team was new, so it's really good work. That's why I switched, and I'm really happy to be in Microsoft. Finally, did 5 problems in Div-3 round. Really nice. Problem F and G both are on graph. I have some idea about F, but for G, even I haven't read the problem. I actually gave a contest after like 5 months, I think. So like I actually got stuck on the very first problem only. I wasted like 15 minutes on the very first problem, and still I couldn't get any answer because I was actually trying to find out all the values, and there was some problem with my implementation. Then I skipped first problem and solved all the other problems. Then I came back to first problem and realized that okay, I can even hard code it. Some audio issue. Is this for everyone? Kanan says. Is the audio issue for everyone? If that is so, then I'll just take my audio. I don't think there is some audio issue from my end. Maybe due to some network error. If you want, I can increase the volume. Okay. Yes, audio issue in between. 2 people are saying. Let me just check if I can do something about it. Okay, I have increased my audio, and that's all I can do. I don't think there's anything else I can do for the audio as of now. Alright, so I think I should not waste any more time, and we can start with the problems. Okay, it's already been 5 minutes since I'm live. So let's not waste any time. Let's start with the very first problem. Mm, by the way, it's a different setup for now, and I'll be using this setup only. So if there is any issue you are seeing with the setup, just let me know if the font size is small or anything. But yeah, E question was directly of GFG. This is unfair. Is that so? I didn't really know about that. If yes, just paste a link in the chat and I'll see if it's the exact same question or something similar to that. Bhanu says, how do you deal when you are an expert and got stuck of problem B of Div-3? You're not getting logic of B and getting wrong and wrong again. It's fine. Sometimes you actually do get stuck. It's better to just leave the problem for some time, come back to it later and solve the rest of the problems, because otherwise you'll actually be wasting a lot of time in that. Hitachi says there's a weird audio sound roughly every 15 seconds. Okay. Uh, I don't know what it is. Maybe after the stream, I'll just go back into my stream and see what the issue was and then figure it out for the next stream. But as of now, I can't really do anything. Saurabh says, thanks, sir. Vikas says, okay. Okay. Let's not waste any time. I'll start with the very first problem, which is polycarp and the day of pi. Now, this is something which I think, wait, how many? 19,000 people were able to solve. So I think almost everyone solved it. So the problem says that on 14th March, the day of number pi is celebrated all over the world. It is a very important mathematical constant equal to the ratio of the circumference of a circle to its diameter. So that's the general definition of pi. No use into this problem. Polycarp was told at school that the number pi is irrational. Therefore, it has infinite number of digits in decimal notation. He wanted to prepare for the day of the number pi by memorizing this number as accurately as possible. Now, Polycarp wrote out all the digits that he managed to remember. For example, if Polycarp remembered pi equals to 3.1415, he wrote out 31415. So he removed the decimal place basically. Now, Polycarp was in a hurry and could have made a mistake. So you decided to check how many first digits of the number pi Polycarp actually remembers correctly. Now, so basically there are t number of test cases, and in every test case you are actually given a string. Why I am saying a string? Because the string n contains up to 30 digits and you cannot really scan that into an integer, so you need to take the input as a string. Now, you're given the string, you need to see till how many digits it is actually same as of the value of pi, and then you need to return that length. That's it. That's all you have to do. Now, one way would be that you say that okay, pi is actually equals to 22 by 7. So what you do is you find out that okay, 22 by 7. Okay, I'll just show you like what I'm trying to say. So one way would be if you say that okay, my pi is actually what, 22 by 7, which is actually like 3.1415, and you actually start calculating this value. You calculate it till 30 digits, then you form the string, and then you move forward. Then you check with the given string and then see like how many values are same. Okay. The other way is because you know that it is actually in the problem, it is actually given that string n contains 30 digits. That's all. Okay, string n contains 30 digits. So what you can actually do is you can just write in your code. You just have to Google that. Okay, give me the 30 digits of pi. You'll get the string, and then what you can do is you can just hard code this pi to those 30 digits. You don't really need to write an implementation to find this value. Okay, and that is why this problem is actually a div3a problem, because you just have to hard code the value of pi and then compare it with the given strings. That's it. That's all you have to do. Okay, nothing major, no implementation as of now. Okay, you just have to Google the value of pi, hard code it, and then just check how many digits are same. So I'll just show my solution for this. Okay, so I'll show you my code. So see, this is what I did. I actually hard coded the value of pi, and then okay, I hard coded the value of pi here. Okay, and then after that I just checked for the entire string. Okay, which all characters are same. If the characters are same, continue. Otherwise, I mark my answer equals to I and then break. That's it. That's all you have to do. And yeah, I think everybody was able to do. If not, this is how you do it. Maybe you are someone who actually calculated the value of pi and then solved this problem. If that's the case, it's a good thing that you did that. But in terms of time, you actually took a lot of time in implementing that, which is of no use in terms of a competition. Okay, so yeah, it's better to actually hard code the value. And okay, all right. So moving forward, I think nobody has any problem with the very first problem. If they have any issues with the very first problem, I can just repeat everything, or they can just ask in the chat. Let me read the chat for now. ओके सो लास्ट स्ट्रिंग को सबसे चेक करना था लूप से जहाँ चेंज होगा वहाँ ब्रेक करके कांट रिटर्न वाला था ओके एनीवन नोज हाउ टू सॉल्व प्रॉब्लम बी आई विल कम टू प्रॉब्लम बी नाउ आई सॉल्व 4 प्रॉब्लम्स इन दिस कॉन्टेस्ट रियली ग्रेट भानु last test case answer is actually pi. Oh, okay. I didn't really see to that. If that's the case, you don't even have to Google it. You can just copy the value from the last input. Yeah, this is the value. Oh, okay. The answer forward. Okay, let me move forward with the second problem, which is Taisia and dice. Is my stream still stuck? Can someone let me know in the chat if my stream is stuck? Just look through my phone. My internet connections is good. Why is my stream stuck? Just give me 1 minute. Let me see what's happening. भाई आप regular आओगे क्या? Yes, I'll come regular. Can someone tell me if my stream is stuck? I have a feeling that it is stuck. If yes, that's the case, just let me know. Now okay, but again stuck. Your stream browsing a bit. Okay. Is it better now? Okay, let me not waste the stream. Maybe there is some lag, but like after the stream is over, you will be able to see the entire stream properly. So I'll just continue for now. Okay. And yeah, let's see what happens. Okay. If there is more lag, just let me know. Okay. Cool. Taisia has n6 dice. Each face of the dice is marked with a number 1 to 6. Each number from 1 to 6 is used 1. A general dice that is there. Okay. Taisia rolls all n dice at the same time and gets a sequence of values a1 till an, where ai is less than or equals to 6, where ai is the value of the upper face of the ith dice. The sum of this sequence is equal to s. So basically, you had n dices and you rolled all the n dices at once. You got some number on every dice. What you did, you marked those numbers as a1, a2, an. Okay, and then you found out the sum of all the numbers, which is actually s. Now, suddenly, Taisia's pet call steals exactly one dice with maximum value ai. So basically, out of all the values of ai, the cat saw this is the maximum value and she took that value. Now, and calculates the sum of values on the remaining n minus 1 dice, which is equal to r. So basically, what Taisia did was, there were n dice. Okay, her cat actually took one dice which actually had the maximum number. Okay, now there might be multiple dices which had the maximum number, but the cat took one dice which had the maximum number. Okay, now Taisia found out the sum of all these numbers as well, which is actually r. Okay, now you only know the number of dice n and the value of sr. Restore a possible sequence a that fills the constraints. So basically, what is given is, alright, so this is input where this is t, and then in every test case you have n, you have what, sum is s, and then you have an r. Okay, now sum s is actually of all the n dices and r is the sum of all the n minus 1 dices. Okay, now if you see, if you subtract s minus r, if you find the value of s minus r, this will give you the value of that dice which the cat stole. Okay, so basically what the question is asking us is, they're asking us to tell a given sequence which was possible. Okay, and it is also mentioned that it is guaranteed that the answer exists. So basically, if you had to find what n dices, let's say, the first value can be said as s minus r. Okay, because there was one dice which the cat took. So this is, let's suppose that this is that dice. You also know that s minus r is the maximum value. This is the maximum value of all the values in this array. Now you need to find all the remaining values. But you also know that the sum of all the remaining values is r. So what you can do is, you can say that, okay, let me see what value I can actually put for this place. What is the minimum value that I can actually put for this place? The minimum value is 1. What is the maximum value that I can actually put for this place? The maximum value is s minus r. Okay, so I need to put some value between 1 to s minus r. Okay, now how do you decide what value to take? What you can do is, let's say, so basically the first value was s minus r, and then you had some values. Okay, let's say these are x indexes. What you can say is, since you know that the sum of all these values is r, you can say that the value of this is actually r minus x. What I'm trying to say is that I'll actually fix all the other values by 1. Sum of all these values actually become x now. That means I can place r minus x for this index. But you also know a maximum value that a dice can actually take is s minus r. Usually it is 6, but since we know that the maximum value was s minus r, what you need to do for this place is, you need to find out what is the minimum value. Minimum value of s minus r comma r minus x. Reason? S minus r is the maximum value that a place can take, and r minus x is the total value that you're left with if you place all the other values by 1. Okay, so let's say you say that this is the value that I am going to take for my next index. Then what you do is, after doing this, you actually subtract this value from r, and this actually becomes your updated r for all the rest of the values, and then you repeat the same approach. Okay, I'll take one example and try to explain. Okay, so let me just do this again. What's happening? Okay, so let me take I'll take this example. Okay, so what did we have? We had 5 indices. Okay, basically 5 dice. Okay, total sum was 17 and r was 11. Okay, now we know that the very first value is s minus r. So when you see s minus r, your s minus r is actually 6, which is 17 minus 11, that is 6. Now, sorry. Now for this place, okay, you know the maximum value that this can actually take is s minus r. Okay, but you'll have to find the minimum of s minus r and r minus the number of places that you have. The number of places that you have right now is 3. Your r was 11. So this r was actually 11. And s minus r, what was s minus r? Your s minus r was actually 6. Okay, so 6 and 11 minus 3 is what? 8. Okay, so out of minimum of 6 and 8, 6 is maximum. So 6 is minimum. So you say that this value is 6. And now you decrement your r by r minus 6, which actually becomes 11 minus 6, which is 5. Now for the next value, again you do the same thing. For the next value, you will say that, okay, the maximum value that I can actually take for this one is s minus r, which is 6. Okay, but how many places are left after this? 2 places. And your r right now is 5. So 5 minus 2. This actually gives you 3. So for this place, okay, you are actually going to place 3 here. Okay, and you'll subtract 3 from r, which actually gives you 2. And now if you follow the same approach, you will say that for this value, what is the maximum value that I can take? The maximum value for this is s minus r, which is 6. And then r minus number of places that are left. Your r is 2 right now. Number of places that are left after this is 1. So 2 minus 1. This actually says that the minimum value the maximum value that you can place for this place is 1. Okay, and if you do the same approach, you'll see that 1 will actually come here. So the answer for this is 66311. And if you see, They actually have given a different answer, but if you see, when you find the sum of 6 plus 6, 12 plus 3, 15 plus 1, 16 plus 1, 17. So your total sum is 17, and when the cat takes this value, your remaining sum actually becomes 11. So this is one possible solution. Okay. So I hope the logic is clear. One more thing. So basically, let's say these are all the total places that you had. And let's say you are actually starting from I. This is 0th index, 1, 2, 3, 4. And you are actually at this index. You are trying to find the value of this index. You know that the value of this index is actually minimum of S minus R, comma, R minus number of places. What is the total number of places after this? The total number of this places after this is N minus I minus 1. Sorry, plus 1. Okay, because this is N and this is what? I plus 1. So N minus of I plus 1. That's it. Okay, so that's pretty much it about the logic. Let me show the code as well. Let me see the chart first. Great to see you after so long. Judge what says, saltily, really great. Is it live? Yes, it is live. I am live. Let's move to D. We will soon move to D. So that says, Bhaiya, the first value is fixed S minus R. Now the remaining R values N minus 1 places and remaining sum is R. So we can put equally to all places R upon N minus 1 and then increment some of them by 1 cause of triviality. Yes, that approach is also right. You could actually do that. I think that's easier to implement. But yeah, I did a different approach. I'll show the code for that. But yeah, the logic that Siddharth is mentioning is also right. I'll show the code quickly. Okay, so this is the code. So if you see what I'm actually doing, the first value is S minus R. So I said that the maximum value that any value can take is S minus R. I printed S minus R. So if I had some number of places, I printed S minus R for the very first place. Okay, and then for the coming places, what I did was this thing. Minimum of maxi, my maxi is nothing but S minus R. Then R minus N minus I minus 1. Okay, if you see what I had written was N minus of I plus 1. This actually becomes N minus I minus 1 only. Okay, so this is the total number of places after the given place you are actually trying to find the answer for. Okay, so this actually gives you a value. You decrement this value from R and then you print this value, and that's it. That's all you had to do. So I hope everybody knows how to do this question now. And yeah, if any of you still has any doubt, they can just let me know in the chat and we'll see to it. Let me move forward to the next problem, which is what? Permutation. As I can see for problem B, 14,000 people were able to do. So yeah, relatively many people were able to do the B as well. Alright, so let's move to problem C. Alright, so shall we start with problem C, or is anyone here who has a problem with any issue with problem A and B? If they have any issues, they can just let me know now. Otherwise, I'll move forward. How to solve E? I'll soon come to C, problem E. Sure. Alright. How many people are watching? 12 people are watching. Okay. Okay. Shall I start? How to solve F? I don't think I'll be solving problem F in this stream. How you use CP editor? I am actually thinking of making a video how to set up CP editor because it's fairly challenging for some people, and I used to use CP editor. I don't have any setup as of now. Okay, so I'm actually thinking of installing CP editor on my new laptop, and if I do that, I'll just make a video as well so that everybody else can also follow. Khabu Ghosh says, great to see you after a long time. Thank you. Sachin says, will you solve D? Yes, I'll be solving D. Vikas says, yes, please make video. Okay. Yeah, I'll try to make a video of how to set up CP editor. Okay, let's move to problem C now, which is permutation. A sequence of n numbers is called permutation if it contains all integers from 1 to n exactly once. For example, the sequence 3, 1, 4, 2, 1, 2, 1 are permutation, but 1, 2, 1, 0, 1, 1, 3, 4 are not permutation. So basically, this is a very general definition of permutation. A permutation is nothing but a series which actually has all the numbers from 1 to n, but in a jumbled manner. Okay, no number is actually twice or no number is missing. So every number is actually occurring once and it is in a jumbled manner. It might be in the same order as well, that is also permutation. Okay, but usually it is not. So let's see. Now, Christina had a permutation P of n elements. She wrote it on the whiteboard n times in such a way that while writing the permutation at the ith time, she skipped the element Pi. Okay. So she wrote the total n sequences of length n minus n 1 each. So basically, if you see, in one permutation, you actually have n values. What Christina did was, while writing the permutation, she actually skipped one value. So when she was writing the permutation for the very first time, she skipped the very first value. Then when she was writing the permutation for the second time, she skipped the second value. As you can see in this example, if you see, the permutation was 4213. Now, while writing the sequence for the first time, Christina skipped first value, which is 4. So the permutation came out to be 213. Then, while writing the permutation for the second time, Christina skipped second value. Then the permutation becomes 413 and so on. Now, you know all n sequences of all n of sequences that have been written on the whiteboard, but you do not know the order in which they are written. So basically, the order of all the permutations have been jumbled. So basically, you had n permutations, and now those permutations are also jumbled. Okay. Now they are given in arbitrary order. Reconstruct the original permutation from them. For example, if you know the sequence 421, 423, 213, 413, then the original permutation will be 4213. So I don't think I need to take out any example, any other example. We already have one good example. So I'll actually explain from that example only. So what do we have? We have these permutations. Okay, let me just zoom it. Okay, what is the original permutation that you actually had? The original permutation was what? 4213. Okay, so the original permutation was 4213. Okay, so this is the original permutation. Now we know that if you actually see in this, what is the first value? The first value is 4. Okay, let me write all the permutations in order. So basically, when Christina wrote the very first permutation, she had to skip the very first value. So she wrote 2, 1, 3. Next time she had to skip 2. So she wrote 4, 1, 3. Next time she skipped 1. So she wrote 4, 2 and 3. Next time she actually skipped 3. So she wrote 4, 2, 1. Okay. Now if you see, there's only one time which is actually the first occurrence of this permutation when she skipped the very first value. So if you see in all the other permutations, the first value is 4 only. So if you actually scan all the permutations, see what is the first value of every permutation and see which value is actually occurring n minus 1 times. That value will be your first value of the permutation. That's it. So basically you had 4 3 times. This actually meant that 4 is the very first value of the permutation. So you now have 4, but you are left with 3 more values. Now you also can see that if you look at the very first permutation, you know that this is the permutation in which 4 was skipped. How you know about that is because this is the very first permutation in this, but if you even look at in the arbitrary order, there is only one permutation out of all these 4 permutations in which this 4 is not coming at the very first index. And by that you know that this is the very first permutation. Through this you can say that this is the second value, this is the third value, and this is the fourth value. So you can say 2, 1, 3 are the rest of the remaining values. Because these 2, 1 and 3 are in order. They just skip the very first value, which was 4, which we found out by seeing all the other permutations that okay, all the other permutations had 4 in the very start. That means 4 is the very first value of the permutation. Then you saw that there's one permutation which doesn't have 4. That means that is the very first permutation that Christina wrote in the order. Okay, and through that you can find the second, third and fourth value, and that's it. I'll do the same thing with another example. Let's see this example. Okay, if you see this example, you can see that every permutation actually has a 4 except this permutation. So 4 becomes the very first value. Now you are left with 4 more values which you can find using this permutation, because this permutation doesn't have 4 in the starting. That means all the remaining values are in order, which is 2, 1, 3, 5, and this becomes the answer. Okay, that's it. That's all you have to do for this problem. I hope the logic is clear to everyone. I'll show the code as well. Now, the way you could actually find the very first value, there are many ways of doing it. What I did was, I actually took the first value of all the permutations. So I had 4, 2, 4, 4, 4. Now I sorted this permutation. So I got 2, 4, 4, 4, 4. Now I saw, is there any, are there any two consecutive indexes which have the same value? If any two consecutive indexes have the same value, that means that is the very first value. Because we know that out of these n values, n minus 1 values will be same, only one value will be different. Okay, so you know that there are no two such values. So since you know that only one value will be n minus 1 times, if you see any value which is coming consistently for 2 times, that means that is the very first value. Alright, so let me just show the code as well. I hope the logic is clear to everyone. Let me see the chart. Okay, I solved it by 2D grid because constraints are low. Okay, Vikas says, अरे ये तो इतना easy था क्या, ये कैसे? Alright, so Vikas says, मैं तो बहुत complex कर दिया था. No, this is a very simple problem. Space क्या says same भाई, मैं तो priority तक पहुंच गया था. Vikas says, भाई मैं second grid में map लगाने figure. Okay, anyways. Alright, so let me just show you the code as well. So as I said, what I did was I actually took so basically I took a 2D grid, I scanned all the values. After scanning, I was taking the very first index of every permutation, pushing it into a vector. Then I sorted the vector, and then I saw in the vector, is there any value that is coming consecutively? If there is any value that is coming consecutively, that means that is the very first value of the permutation. After that, in this part, I'm actually finding the index of all this. So basically, I had this permutation, I had this permutation, I had this permutation, and this permutation. Now I need to find out which out of these permutations doesn't have the first value as this value. So let's say if this was the index, if this was the permutation which didn't have the same value, that means these are all the rest of the values. So I found out this permutation, I marked it as index, and then I printed the first value, and then I printed all the remaining values of this permutation, and that's it. So that's pretty much it about this problem. I hope everybody is clear with the problem C as well. Naman Bhaiya, how to break Div-3 C barrier? That is a really great problem question, and I'll actually tell you how to do that. Okay, I'm actually thinking of some playlist. I'll tell you what I'm thinking after all the problems. Okay, and then you can let me know if you want me to break that, if you want me to make that playlist or not. Anyways, let's move forward. What is the next problem? We have done 3 problems till now. The next problem a little difficult to actually pronounce, so I won't pronounce it. I'll just move forward to the problem. Okay. Alright, a different idea can be realized is that the numbers have precedence. I don't know what you're trying to say, Sachin. Maybe you can explain a little bit about your approach as well, and then I'll see like if that's right. Space says, भैया 4 महीने में expert कैसे बने? I'll tell you how to do that. Vikas says, yes, make the playlist. I'll tell you like what I'm actually thinking, and then you can say, let me know. Alright, let's move to the 4th problem. Okay, so this is just some random line which I'm not going to read. Alright, let's move forward. A set of nesting dolls consists one or more nesting dolls. Their sizes are consecutive positive integers. Thus, a set of nesting dolls is described by 2 numbers, S, the size of the smallest nesting doll in a set, and M, the number of dolls in a set. In other words, the set contains size S, S plus 1 till S of M minus 1 for some integer S and M. So basically, if you actually had like, if your S was 4 and M was 3, that means you had 3 dolls, one of size 4, one of size 5, and one of size 6. That is what the problem is trying to say. Now, you had one or more sets of nesting dolls. Recently, you found that someone mixed all your sets in one and recorded a sequence, doll sizes, integers A1, A2 till AN. Basically, what they're saying is, let's say you had one sequence of dolls. Let's say this was 4, 5, 6 only. You had another sequence of dolls. Let's say this was 5, 6. You had another sequence, let's say 1, 2. Someone took all these sequences and made one sequence out of this. So the one sequence would be 1, 2, 4, 5, 6, 5, 6. Okay. Now, for example, if a given sequence A is this, initially there could be 2 sets. If this was the sequence, then there might be 2 sets. One is 1, 2, 3, 4. One is 2, 3. If you combine these 2 sets, you'll actually get this set only. Now, the first set consists of 4 nesting dolls. Okay. According to a given sequence of sizes of nesting dolls A1 till AN, Determine the minimum number of nesting dolls that can make this sequence. So you are given this sequence, you need to tell how many minimum sequences you need to make all these numbers vanish into smaller sequences. Now, each set is completely used. So all its nesting dolls are used. Each element of a given sequence must consider to exactly one doll for some set. So that is the problem. Let me take one input and explain like what the problem is trying to say. Let me just read the chat. Okay, that is the explanation for the previous one. I'll just read this after that. Okay, so let me take the very first input, which is 2, 2, 3, 4, 3, 1. So we had what? 2, 2, 3, 4, 3, 1. Okay, let me just sort these values. If I sort these values, I actually get 1, 2, 2, 3, 3, 4. Okay, now let me just write these in a different manner, which is 1, let's say this is 2, I had another 2, then I had 3, I had another 3, and then I had a 4. Now if you see, you can actually make one sequence as this and the other sequence can be this. So the answer for this is what? 2. And as you can see, it is given 2. Okay, let me take the next example. So what is the next example? Next example is 11, 8, 7, 10 and 9. So we had this as the next example, 11, 8, 7, 10 and 9. Again, if you sort these values, you actually get 7, 8, 9, 10 and 11. And since everything is occurring once only, you can say this is one sequence and the answer for this is 1. Again, let me take some good example. Let me take what? This example only. So what do we have? We had 1, 1, 4, 4, 2, 3, 2, 3. Again, let me sort all the values. So we have 1, 1, 2, 2, 3, 3, 4, 4. Again, let me write these values in a different way. So I have two values of 1, so I'll write 1 and 1. I have two values of 2, so I'll write 2 and 2. I have three values of 3, 3 and 3, four values of 4, two values of 4, so 4 and 4. And now again, if you see, this is one sequence, this is another sequence, answer for this is also 2, and as you can see, answer for this is 2. Okay, I'll take one last example, which is this one. Okay, so let me just clear these. Okay, so the example says we have, okay, let me just sort these values directly. So if I try to sort these values, I have 5, 6, 8, 9, then I have what? 11, 12, 14 and 15. These are all sorted. Okay, but if you see, 7 is missing, 10 is missing, 13 is missing. And dolls actually, one sequence actually needs consecutive values. Okay, so this is one sequence, this is another sequence, this is another sequence, and this is another sequence. Okay, now how do we solve this problem? Okay, alright, how do we solve this problem? Let me just open a notes for this. Okay. So, let's say you had some number of ones. Let's say you had some number of ones. Now let's say you had some more number of twos. Again you had some number of threes. Now let's say you had some number of fours. Let's say this is the entire input. So basically your sequence would have been somewhat like 1, 1, 1, 1, 4 times 1, 3 times 2, 2 times 3 and 3 times 4. How many sequences can you actually make out of this? If you see, you can make one sequence, you can make one other sequence from this. Now, one sequence will be this and one will be this because 3 is missing. And one sequence will be this. So in total, how many sequences were you able to make? 1, 2, 3, 4 and 5. So in total, you were able to make 5 sequences. Okay. Now, how do we actually calculate this 5? Let me show you. So I'll write this pyramid again. We had 1, 1, 1 and 1. Then we had 3 times 2. Then we had 2 times 3 and then we had what? 3 times 4. Now, let's see with this one. This one will say that I'm actually occurring 4 times in the sequence. That means every one out of these will actually make a sequence. Okay, this one will start a sequence and let's see how far the sequence goes. Sequence of this one will actually go till the end. Sequence of this one will also go till the end. Sequence of this one will go till this point only, and sequence of this one will be till here only. How do we actually find these terminating values? If you see, this one will say that okay, start 4 list with 4 sequences from me. So in the answer, you will say that okay, my answer right now is 4 because I'm actually starting 4 sequences. Then you will actually have 2. You will say that 2 is actually coming thrice. Since this 3 is actually lesser than 4. Right now I have already started 4 sequences. The next value actually says that I need 3 sequences. I already have more sequences. So I will say why not combine these 2's with the previous values only. And I'll combine these 2's with 1's. So this 2 combines with this one with this, and this with this. Now when I come on to this 3 will say I have 2 3's. Count of 3's is 2. And this 2 will say that okay, I already have 3 lists ongoing with me. There were 4 lists which actually came to 2, but one got terminated because there were lesser number of 2's. So this 2 will say that there are 3 lists that I am actually owning. I can adjust 3 values in those. But this 3 will say that okay, I only have 2 values. So they will say that why not combine and make 2 lists only. We can terminate one more list. So one more list was terminated, and now you have 2 more lists. But your answer is 4 only because in the starting you started with 4 lists and they are still going on. Now the next value 4 will say that my occurrence is 3, but only 2 lists are coming. That means this 4 will say 2 out of these 3's, like 2 out of these 3 values will actually join with 3. One new sequence will be started because this 4 will say that okay, I need another sequence because I don't have any number of 3's for me. So you will say that okay, 3 is bigger than 2. That means you need to add 3 minus 2 to the answer, which is 1. So add 1, meaning that there is one new list that is starting. And now if you see, there are 3 more lists that have started. Okay, but since there are no other values, this becomes the final value, which is 5. Let me take a better example. Okay, so let's say you had some number of 1's, you had some number of 2's, you had some number of 3's. Then let's say you didn't have any 4. Then you had 1 5, you had 2 6. Okay, and then let's say you had no 7's, and then again you had what? Once. Okay, let me just make this one only a little complex. So let's say you had what? 3 5's, then you had 2 6, and then you had 3 7's, and then you had 1 8. And we need to find how many sequences will be needed to cover all these values. Okay, now if you see what is the count of this one, count of this one is 3. So my answer will say okay, take 3 for me. Okay, because there are 3 new lists that are starting from this one. Then I have 2 which again has count of 3. So these 2 will say I will join the previous list only because previous count is also same. So nothing changes. I have 3 lists coming on. Now this 3 will say my count is 2. But since my count is lesser than the previous count, I will adjust in the previous sequences, previous list only. And right now I have 2 more lists coming on. Okay, so when I come to the next value, which is 4, I will see that count of 4 is 0. That means I need to terminate all these lists because there is no other value to attach to the given sequences. So this was 0 and nothing changes. Now I'll come to the next value. 5 will say I have 3 occurrences, but there are no sequences coming. Since there are no sequences coming, I need to start 3 new lists. So I'll add 3 to the answer. Now I'll come to 6. It will say I have 2 values. Okay. These 6 will say since the previous count was larger than my count, I will adjust in the previous list only. And I'll terminate one list. So now there are 2 lists going on. And now when I come to 7, I will say my count is 3. This 7 will say I need 3 lists, but there are only 2 lists coming. So I'll start one list by myself. So since there is one new list starting, I'll say add 3 minus 2. 3 is the count of current one, 2 is the count of previous one. So 3 minus 2. Now again, now I have 3 lists because 2 lists I already had, 1 list I started. Then I come on to 8. 8 will say my count is 1. Since 1 is lesser than 3, nothing happens. And this is my final answer, which is 3 plus 3 is 6 plus 1, 7. 7 is the answer for this. And that is how you had to solve this problem. I hope the logic is clear to everyone. I'll tell how you had to implement it. So basically the way my implementation is, you scan all the values and you insert all the values in a map. Okay, so basically map will say 1 is occurring thrice, 2 is occurring thrice, 3 is occurring twice. I'll skip 4 because there is no occurrence of 4. Then I'll say 5 is occurring what? Thrice, 6 is occurring twice, and 7 is occurring thrice, and 8 is occurring once. This will be my map. Okay, then I'll say my last value is 1. My last count is actually 3, and my answer is also 3. And I'll move my iterator to the second value, because for the first value I've already calculated the answer, which is 3, and I have a list starting from 1, and there are 3 lists that are going on. When I come on to 2, I will say my new count is equal to the previous count. So don't do anything, just update the last value, which is 2 now, and nothing changes. Then I come on to 3. This 3 will say my count is lesser than the previous count. So just change the previous count from 3, just a second, from 3 to 2, and last also changes from 2 to 3, because right now the most updated value is 3 and nothing changes to the answer. Then I come on to 5. I will see that my 5 is actually greater than 3 plus 1, because the next value that I was expecting was 4, but I'm actually getting a 5 here. Since the value is jumped by twice, I will say I need to terminate all my previous list. So I terminate all my previous list. I say my last actually now becomes what? 5, and my last count now becomes 3, and I need to add 3 to my answer because I'm starting 3 more lists, and so on. That is how the logic will keep on going. I'll show my code as well. Let me just show my code. And let me see the chart as well. How did you implement? Just a small hint. I use the previous to show the last element, that is minimum, and then check with the current minimum. Yeah, somewhat similar. I want help in solving E. We are coming to that. Sharon says use same waiting for E. Read waiting for answer of space cadets question. Okay, what was okay? He was asking how to crack the Div-3 bar. Okay, how to get expert in 4 months. Okay. Real life says for problem D, I sorted array in decreasing order and took multi-set. Then I started iterating an array and I took the array plus 1 set. If found, I raised it and put current. Yeah, that is the same logic. Alright. If you used map real, yeah, sorry, request insta pe request accept kar lo please. Okay, I'll do that. Not able to solve number theory problems. Okay, I'll tell you how to get better at number theory problems. Okay, because I was also stuck at number theory problems at some time in my life. Okay. Now this is the code. Again, same thing. I have 3 variables: last, answer, and last count. Okay, so I have 3 variables: last, answer, and last count. Okay, I set it with the very first index. Then I iterate over my map, and in the map I'm just checking if my next value is 1 greater than that. That means I can actually use these values for the next sequences. Otherwise, I need to add every value. Okay, so that's it. I hope the logic, the code is pretty explanatory by itself, because I've already explained the logic entirely. If not, you can just spend some time onto this code and you'll be able to understand. Okay, now let's move on to the next problem, which is what? Let me read the chart as well. Number theory tips needed. Okay, I'll tell this in the end. Now let's move to the problem E, which is something that everybody is waiting for. And I'll tell you how I solved the problem and like how I actually came to the logic. And then like you can just see, like you don't really have to know the exact thing. You can also like write some brute forces to understand like how the answer is coming. So let me just read the problem. Alright, so Wallet found 2 positive integers a and b. Both a and b are greater than 0. He discovered that a XOR b, this is XOR, a XOR b is equals to a plus b by 2, where XOR means the bitwise exclusive OR, and division is performed without rounding. Since it's easier to remember one number than 2, Lard discovered only A's or B. Let's denote this number as X. So basically this number is X, this is also X. Help him find any suitable A and B and tell him or tell them or tell him that they do not exist. Now the first line of the input contains single element T, that is the number of test cases, and then you have X. X is ranging from 1 to 2 to the power 29. So basically X is somewhere in the range of 10 to the power 9 only. Okay, so you can't really write a brute force for all the numbers. Now, so let's look at the examples. So if my very first test case is 2, the answer is 3 and 1. And as you can see, 3 is represented as 1 1 in bitwise, 1 is represented as 0 1. And if you find the bitwise XOR, you will see 0 1, which is nothing but 2. And if you see 3 plus 1 by 2 is also 2. So this is one valid answer. Similarly, let's take another case. What's happening? Okay. Let's take this 10. For this 10, if you see, we have 13 and 7. How do we write 13 in bitwise? 13 in bitwise is actually what? 8 plus 4 plus 1. So we have 1, 1, 0, 1. Okay. And then how do we write 7? 7 is nothing but 0, 1, 1, 1. If we try to find the bitwise XOR, so this is 7. If we try to find the bitwise XOR of these values, 1 and 1 gives us 0, 0, 1 gives us 1, 1, 1 gives us 0, and 1, 0 gives us 1. What is this? This is nothing but 10. And if you see, 13 plus 7 by 2 is actually 10. Okay. Now, how do we actually solve this problem? I'll tell you exactly how I solved the problem. So basically, I read the problem. I was a little confused like how to solve it. Okay, I was not getting any answer. Then I actually observed one thing. If you see this 10, the answer is 7 and 13, which is obvious because what they are doing 10 plus 3 and minus 3. So basically, if you have a x, one value will be x plus y, other value will be x minus y. Because if you see, if one value is x plus y, the other value is x minus y. If you add these two values, divide by 2, you will actually get an x. Okay, so your answer is actually always of the form x plus y, x minus y. This is something I actually observed from the input only. Then I came on to the last input, which is 36. And I saw that, okay, there is one answer, 2250. Okay, what I wanted to know was, okay, just a second. Okay, what I wanted to know was, is there any answer for this? Okay, so what I did was, I just wrote a very simple brute force that, okay, since I already know about this pattern, try for all the values for 36. So basically, if you have 36, I wrote a brute force which actually tried for what? 37 and 35. Found out the XOR of these values. If the XOR is equal to 36, it pretended that, okay, these are two more values. Then I tried this for what? 38, 34, and so on. And with this, I actually saw that there are two answers for this. One is 50 and 22. The other answer was 18 and what? 54. Through this, I saw that, okay, 18 is actually 36 by 2. Okay. And for 10 also, I actually observed that there are two answers. For 10, if you see the two answers, okay, let me just erase everything. So, we know that our answer is of the form x plus y and x minus y. For 36, through brute force, I actually observed that, okay, there are two answers. One is 50 and 22. The other answer is 54 and 18. And if you see, 18 is nothing but 36 by 2. Then I actually thought about a pattern that, okay, maybe for 10, the answer is what? 10 by 2 is 5. So maybe the answer is 15 and 5. I tried the XOR of this and the answer came out to be 10. Through this, I actually came upon a logic. Okay, so the answer is this only. All you have to do is see if x plus x by 2 XOR x minus x by 2 is equals to x. If this is true, this is A and this is B. That is the entire logic you have to see. Okay, but what is the proof around it? I'll tell you now. But even I actually thought about this logic, saw the pattern, submitted the problem, got an accepted, and then I thought about the logic. Okay, so yeah, it's okay if you even have found out a pattern, you're confident about the pattern, and then you just code the pattern and then just get an accepted, and then later you try the proof. I had some idea that, okay, this will work. That is why I just tried to submit the problem. Now, alright, so now what is the proof behind it? If you see, let's take some number. Let me take 10, 10, 10. Let's say this is x. What is x by 2? My x by 2 will be nothing but 1 0 1 0 1. This will be my x by 2. Okay, what will be my x plus x by 2? My x plus x by 2 will be 1 1 1 1 1 1. What is x plus x by 2? XOR x minus x by 2. So x plus x by 2 is this. X minus x by 2 is nothing but x by 2 only. So I'll write what? 0 1 0 1 0 1. What do we get when you find the XOR of these two values? You actually get 0 1 0 1 0 1, which was nothing but x. That is how this is working. Now, why only these cases are working, I'll tell you. Basically, if you see, why did I take this example? An example in which we had 1, then 0, 1, 0. Why can't we take a very simple example, let's say 1, 1, which actually have two consecutive ones? If you see, when you divide this by 2, you don't get like 0, 0 or something, you actually get what? You actually get 3 by 2 is nothing but 1. Okay, so you get 0. So you are losing some data here. And if you lose out some data, then this formula won't work. Okay, so basically what I'm trying to say is that the first bit has to be 0. It has to be an even number, then only this will work, because otherwise if I divide this by 2, I'll lose out on some data and this formula won't work. The other thing is I cannot have two consecutive ones. The reason is because let's say I had 1 1 0 1. Okay, 1 1 0 1 0, let's say. Okay, what is x by 2? This is x here. What is x by 2? I cannot say like my x by 2 is like this. Okay, because for this one it will be 0 1 only, but for this is what? For this it is actually going to be even, let me think. So this is 8 plus 4, that is 12 by 2 is 6. Yeah, for this it will actually be what? 0 1 1. This will be the XOR, like x by 2. And if you see, after finding the XOR of these two values, you don't really get this back. Okay, that is why you cannot take two consecutive ones. But if you just write this logic, that okay, if x plus x by 2 or x minus x by 2 is equals to x, then just print the values, otherwise print minus 1. That is all. You don't really need to write these two edge cases separately. Otherwise, these are the edge cases actually. If you write just this formula, then everything will work fine. Otherwise, you have to first see that okay, if x is even, and then you have to see if the decimal representation of x doesn't have any two consecutive ones. If it has any two consecutive ones, then the answer is minus 1. Otherwise, you can find the answer. But again, to find the answer, you will use this formula only, or maybe you can even try some brute force. There are some summations which I've seen which actually do a brute force after looking for these two conditions. Okay, so that's it for problem B. Let me just show the code as well. Again, not much into the code, but I'll show the code. Alright, so as you can see, what I'm actually doing is, okay, what I'm doing is find out the value of n plus n by 2 and XOR with n minus n by 2. If this entire value is equals to n is nothing but x actually here, then print n plus n by 2 and n minus n by 2. Those are the answers. Otherwise, print minus 1, and that's it. That's all you have to do for problem E. Alright, so let me see. I'm waiting for question based on tree. I'm not going to solve the last two problems which are based on trees. Jay Kati says, in E I use x plus x by 2, x minus x by 2 and check condition given. If yes, print A and B, otherwise print minus 1. Yes, exactly, that is the same thing that I told. Alright, Vikas says heart helium 3. I had a problem which I see a tree or graph question, and if I start thinking in tree or graph mindset, then I cannot solve it by array or constructive mindset. What to do with this? Just do a lot of practice. This problem will be solved by practice only. Now, 6th try kiya tha. Okay, anyways. Okay, I hope this is clear to everyone. The first 5 problems are clear to everyone. If not, if there is any doubt that you have, then you can just ask me. Otherwise, we can end the stream. Or if there is any other general question you want to ask me, you can just ask me. Else, I'll end the stream. Alright. Number theory. Okay. So, how to get better at number theory? So even I wasn't good at number theory. I actually got better at number theory when I was preparing for ACM ICPC. I'll tell you how I did it. Just go to Geeks for Geeks. On Geeks for Geeks, there is actually a section for number theory. Maths, that is called maths, I think. They've actually updated the UI, so I don't really know what the name is. But there's a section for number theory or maths, and in that section, they have told everything, how Sievert-Ferrostosis works, how Euclid's algorithm works, and everything, how Fermat's-Little theorem works, and everything. So I actually read all the blogs of maths, and after that, I was very confident in number theory. So yeah, you can try the same thing. Okay, आज का Div 3 का level कैसा था? It's a very balanced Div 3, I would say. Not balanced actually, like problem F and G are pretty difficult for a Div 3 round. But yeah, problem from A to E, they are balanced, as you can see from the submissions. In the very first example problem, you have 20 submissions, 20,000 submissions. Then you have 14,000, then 10,000, then 6,000, then 4,000. It would have been better if problem F had like somewhere around like 1,500 submissions. Then it would have been a more balanced round. But yeah, even this is okay. If for a Div 3 person, you are able to solve like first 5 problems, that is pretty good. And yeah, if you're able to solve the first 5 problems, I'm pretty sure you'll become an expert. Alright, any other questions that you have? JK3, if any hint of some or something. No, I don't really have any idea. I think it will be done something using BFS, but like my BFS solution was getting a timeout. So I'm not sure. Is the aptitude number system question help for number theory? Yeah, if you have a good aptitude, it's easier. Number theory actually becomes easier for you. But yeah, even if you don't have, you can learn that through practice. 6 Euler 2 से हो सकता है क्या? I don't really have any idea about that. Okay, any other problem? We have 18 viewers right now, I think. Just let your friends also know, because I'll be starting with these streams again. I had so many comments, so many messages about starting the streams. That's why I'm actually starting these. And I'll also be posting some more content. So just let me know if you want any other content for me to post. I'll make some videos for that. You were telling something about playlist. Yeah, okay. So someone asked me how to like pass the bar of Div 2C. Now, Div 2C is actually a problem which, if you are able to solve, you will become an expert. Okay, if you are able to solve the first 3 problems in what say like 1.5 hour, you will definitely become an expert. And like A and B is something that everybody is able to do without actually investing time in CP. But to actually solve C, you need some practice in CP. How do you do that? There's actually a very good platform known as A2OJ. It used to be somewhere in my time, but now if you go to A2OJ, it has been shut down by the author. So there are many web apps that people have made. So you can just try opening any one of those web apps, and it is actually a list of 100 problems for every like section of problems. So if you go to Div 2C ladder, they actually call that a ladder. So there are 100 problems in that ladder. If you solve all those 100 problems, I am 100% sure that you will be able to solve problem C in every contest. This is what I did actually. I solved all those 100 problems. I was actually preparing for ACM ICPC with my friend. So we solved all those 100 problems together. And after solving those 100 problems, I was able to solve every like problem C in every contest. So just give those that actually a shot. Maybe you will also be able to get better at CP. What topic has to be mastered? Number theory, binary search first. I would say binary search. Sharon says bye, good night, bye. Anything else? Otherwise, I can end the stream. We have already had the stream for like 1 hour 5 minutes, and it's better not to stretch the stream. We have another contest. What is the next contest? The next contest is actually a group contest of Div 1 and Div 2, a 3-hour long contest on 29th Jan. So I will again be covering that as well. I'll start at 8 till 10, 11. It's the contest only, so I'll probably come live at 11:30, and let's see how many problems we are able to solve on that. Vikas says, sir, ab se rozana. I can't really come live every day because contests are not there every day. But yeah, whenever there is a contest, there are actually many contests. We have a contest on 29th Jan, then we have a contest on 1st Feb, then 3rd Feb, and so on. So like many contests are coming. So I will, okay, we have a Div 4 on 3rd Feb as well. Very nice. We could solve problem according to rating on Codeforces, that will work same way. No, that doesn't really work the same way, because on Codeforces there are more than 10,000 problems. So you can't solve every problem. Okay. If you want a curated set of good problems, okay, you can actually go to an A2OJ ladder for problem C. You will get 100 very good quality problems, and like every problem actually has a concept in it. So there are some very, like someone actually really spent a lot of time in figuring out what those 100 problems should be and then made that list. So yeah, do give that 100 questions a try. The coding animation says how to solve C if this is difficult, and how many times do I try to do this? Are you talking about the C for today's Div 3 or a Div 2C? Because there's a huge gap between those two problems. Okay. Okay, I don't think there is anything else left for the stream. I think it's better to end the stream. Let's come live on what 29th Jan again at what 11:30, and yeah, let's solve some problems. In the meantime, keep practicing. Let me know if you have any issue or problems or anything. Just comment down below. Okay, I will definitely help you out. Ankit says, "What's your plan for this channel?" I actually plan to invest a lot more time in helping people get better at competitive programming, because competitive programming is something which actually helped me a lot in getting interviews and like jobs. So yeah, that's my plan. Sir, jawline अच्छी है आपकी. I don't think so. You're highly mistaken. Okay. All right. So, bye bye. Thank you for watching. Do subscribe to the channel if you are not subscribed yet, and also tell your friends as well. I will be coming live for every contest now. So yeah, it will be great for help for those people as well.